Hello. I have an echo. Okay, I should have no longer an echo. So I'm going to restart this in just a moment to give a clean intro to Susie. But before I do that, I wanted to let you know I'm having a weird day. I am at some point in the next 36 hours expecting a phone call from AT&T to try and resolve a very expensive screw up of my local AT&T store. It's one of those phone calls I have to take. So, if you want to know details, I tweeted all about it. You're welcome to go look. Star Strider, spelled with a Y. But our goal for today is to actually be here to discuss science. I just want to let you know that might be happening in advance while I work on finishing opening files. So I need to talk to them. Hopefully it won't happen during this episode because that would be sad. Other than that, I am just opening up today's notes. And as soon as I have those open, I'm going to go ahead and get this episode started. This is my first episode back after being in Hawaii for the American Astronomical Society meeting. And it appears that somewhere along the lines, I misplaced all my icons. That's all right. I can still find my software. It just takes me a minute. For those of you who don't know what you've tuned into, this is about to be our daily news show. I am simply babbling semi-coherently while I work on opening up the notes. All right. Oh, crud. I can't have the chat on my phone. I'm going to figure this out, people. It's just going to be awkward. All right, here is to figuring things out. I can do the thing, people. I can do the thing. Maybe. I'm not convinced. This may not be Monday, but it sure plays one on the internet. Okay, here we go. Sliding the teleprompter in. Making sure I am connected. Getting things up so that they are aligned. Thank you for the thing. I can't see the thing at this distance, but thank you for the thing, human, who I will acknowledge at the end of this episode. Just trying to find. Thank you for the other thing. Oh my God, I have so many dogs right now who all want bits. Okay, I'm gonna have no chance but to go find bits. Hold on. I will start the daily show after I give them both a treat. Move. Move, you evil furry monsters. Thank you. Don't know if you could tell, but the green screen just tried to fall off the wall. That was fun. Oh, hi. Okay, here you go, Malachi. This is Eddie. Malachi is just off camera. But this is not why we are here. We are here for the news. So, thank you for the sub. I can't read who you are. I can just see what icon it is. Thank you. I will thank you by name after I've made it through the episode. All right. There's another sub. Thank you so much. Okay, come on up. One more. Whoa. Hi. Come here. You have to come here. Okay. Thank you. All good things are happening right now. It is glorious. It is glorious. Hi. All right. So it's still, I'm going to switch over to chat and find out what the heck is going on. Gift sub hype. It's gift subs. That is amazing. Who is the source of this? Svavtimya gifted a sub to a whole lot of different people. Svartemya. I feel like this should be a Russian word, but I don't know what the word is. You are awesome. You are an awesome human. Thank you, Svartemia. Thank you. And if you're Russian, большое спасибо. I have no clue if you're actually Russian. That just looks like it should be a Russian word. All right. I'm now going to go back to trying to do this episode. We can do it, people. We can do the thing. We can do the thing. All right. So, Susie, cut after this. This is the Daily Space for today, Tuesday, January 14th, 2020. I am your host, Dr. Pamela Gay, and I am here to put science in your brain. As January enters its third week, we find ourselves looking extra hard at the star Betelgeuse. This giant star is unusually faint, and the prediction is that it should start getting brighter this month. But maybe instead of just normal getting brighter, it will explode and go boom and get really, really bright. Maybe, but probably not. But still, as we eagerly watch, we aren't seeing it get brighter yet, and we all have supernovae on our mind. One of the most common questions that we're getting around here is, do we need to worry about a gamma ray burst from Betelgeuse? And more specifically, do we need to worry about one hurting us? Well, thanks to new research from the University of Warwick, we now know the answer is a double no. We already knew that Betelgeuse wasn't pointed our way, so if it did generate a gamma ray burst, it wouldn't have hit us. Now we know that this singular star shouldn't even be able to generate a gamma ray burst to begin with. It turns out that it takes 2 stars to make one gamma ray burst. In research led by Ashley Crimes and published in the monthly notices of the Royal Astronomical Society, scientists report that only massive stars and binary systems can generate bursts of gamma rays. Long gamma ray bursts, which can last from several seconds to several minutes, are generated when stars around 10 times more massive than our sun collapse and then explode as supernovae. The mystery had come into what caused some systems to have jets with gamma ray bursts of radiation, while others didn't. It didn't appear to be a result of different star compositions. And by modeling thousands of binary systems, this team of researchers realized that the issue isn't actually composition, but rather it's one of geometry. Some systems are able to transfer momentum from the surviving star to the exploding star, spinning it up and driving the formation of jets, while the surviving star dashes away. What I particularly like about this result is that while it's based on models, it makes predictions that can be observed. According to Crimes, this model allows us to predict what these systems should look like observationally in terms of their temperature and luminosity, and what the properties of the companion star are likely to be. We are now interested in applying this analysis to explore different astrophysical transits, such as fast radio bursts, and can potentially model rarer events, such as black holes spiraling into stars. This result is just pleasing, and I look forward to seeing what more this team figures out as they move forward with this research. Let's face it, stars, even individual stars, are often harder to understand than seems rational. It is particularly amazing when researchers make claims about what they believe can be learned from one random star orbiting through the Milky Way. According to astronomers from the Max Planck Institute for Solar System Research, the star Nu Indi can, on its own, provide enough information to date our galaxy's collision with the Gaia Enceladus dwarf galaxy. Here's how they did it. They looked at the composition and claimed that this star formed in the halo. Its current position and orbit, however, mean that it got sent tumbling into the disk of the galaxy. By working out this star's orbit backwards, they concluded that interactions during our Milky Way's collision with the Gaia and Enceladus system 11.5 billion years ago changed the star's orbit. I'm going to admit, this research seems a little bit of a stretch to me, but while I'm not convinced they're absolutely right, everything they are saying is consistent with everything they are observing. I'm just not willing to say that this is the only explanation for this star's position. But this is a reminder that science is a process and a dialogue. We say what we think is true and argue for why it is true, and then we wait to see if we are proven or disproven in the course of time with further observations and better data. I want these folks and their far out set of conclusions to be true, and here's to hoping that more observations and time bring more confidence to these results. The fact that science is an evolving story is often lost in the moment-to-moment telling of the story. As we gather more data, our understanding must adapt, and yesterday's explanations don't necessarily match today's truths. Nowhere in science is this seen more clearly than in our study of climate change. As we get more data, and as the world around us changes in ways we didn't know was possible, our understanding of the future has to constantly cope with this new data. Several months ago, the new data we were trying to understand is the impact of Brazil's wildfires. In a new paper in Science Advances, Paulo Brando and his companions, or colleagues rather, report that by the year 2050, the emissions from fires could release more carbon than the remaining forests are able to sequester. This means that the forests of Brazil, with recurring and increasing forest fires, could become a carbon source instead of a carbon sink. This paper was written and submitted before we understood the horror that is this year's Australian bushfires. In the next couple of years, we're going to be learning how our world responds to climate change in ways we previously never imagined. So far, all of the surprises have been seen in the direction of things being worse than we imagined. I don't know what the answer is here. Plant every piece of land and be careful of every spark of fire. Be good to one another. This is all we know right now. And this is all I've got. This rounds out our story for today. Thank you all for listening. The Daily Space is produced by Susie Murph and is a product of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are here thanks to the generous contributions of people like you. We want, if you want to become a supporter of the show, check us out over on patreon.com/CosmoQuestX. Now I am going to try and answer your questions, and I'm really hoping that Twitch didn't eat the chat. No, the chat is all here. We are good today. We are good. So I'm scrolling up to the top to see what all we've got. Hey, Simple Organism. Hello, Mythtown. Hello, DPI209. Hello, Checker Kev. Hello, Paranor. Hello, Hanny's Vorverp. My vacation was quite good. My husband would like to go on another one, and so we will in December. Hello, Guido. Good to know that the audio is fine. Hello, Broken Symmetry. Scrolling. Hello, Binary Blaze. Hello, Mythtown. Hello, Larry. Hello, Michael Mayer. Hello, DPI209. I think I may have already said hello. So hello twice. Hello, Planetary Pan. Hello, Fenring. And thank you for 18 months of subscribing to our channel. Thank you. Scrolling. Yeah, I think I did say it's Monday. It's actually Tuesday. It's just a Tuesday that feels like a Monday. Yes, we use a teleprompter a lot, Hanny. This is just so I can keep names and publications and things like that straight. We do have floofs everywhere. There are 2 floofs down here, Malachi and Eddie. You're right. That is How to Disrupt Video Conferences 101. Stella was down here earlier. Binary Ablaze taught her not to be afraid of the basement stairs, but she found a rawhide and she carried it away to eat it without the other 2 dogs. Let's see. Thank you again, Svartmia, for the gift of subs. Thank you. Larry asks, who is the alpha here? I usually am, but when treats are involved, I don't think there's anything other than talk to the paw from Eddie. Looking to see what else is in here. So, hello, Get a Star. Gittis Attar says, has someone said Betelgeuse enough times to get it to explode yet? No, I'm afraid it just hasn't worked that way. Eddie did totally miss treats. We did have dog sitters staying in our house. So he got love in humans, but he just didn't get the treats that he's used to. Let's see what else we have in here. And while I'm scrolling, I just want to give a special shout out to both Binary Blaze and Susie Murph for holding down the fort while I was off in Hawaii. We could not have done everything that we did last week without their constant help, time zone conversions, support, and just ability to get stuff done. So Binary Blaze, Susie Murph, you guys are awesome. Thank you for being the best crew a project could have. And Paranor, I almost left you out. Didn't mean to. Just, I screwed up. Paranor also co-streamed a ton of stuff. And he's kind of like the hidden volunteer that really is this constant. He knows how to do stuff on the channel the rest of us haven't had to figure out because he's so awesome working in the background. Hello, Wayne Johnson. Oh, more bits. Scrolling. Thank you, Wayne Johnson, for the bits. Wow, I have 2 dogs staring at me with an intensity that is amazing. I know I forgot the slides, Binary Blaze. I realized that only after I finished, and unfortunately, hi. I didn't have the chat where I could see it. I mostly got things set back up, just not completely. Not completely. I like that Hanny is trying to telepathically get Betelgeuse to explode. I appreciate that. So Kerbal asks, what is the most interesting thing at AAS? That one's hard to answer because it was a really weird meeting because there was so much intensity put in to discussing both the 30-meter telescope on Mauna Kea and Starlink. And neither of those are science, but in a way, they were the most interesting thing because what we saw was the people of Hawaii so often arguing, this is our land, this is our culture, this is our heritage. We are trying to protect it. And the astronomers going, no, we need to do this for science. At the same time, Starlink is arguing, but we're trying to get internet to the world while the astronomers are going, no. You can't launch Starlink. This is our cultural heritage. We have to protect the sky for the next generation. And so we had the astronomers using the same argument against Starlink that the Hawaiians were using against the 30-meter telescope. And the irony of this seemed to be lost on everyone. In terms of what was the most interesting science, I don't know. There was so much. There was so much. Okay, Henny asks, when the Milky Way eats a dwarf, how do the new stars start to orbit in the correct direction? Does it take long? So it turns out that not all the stars end up orbiting in the correct direction. Our galaxy has lots of stars that are going entirely the wrong direction. And in fact, we have a suite of globular clusters, entire clusters of stars in the halo of the Milky Way that are going in entirely the wrong direction, that appear to all be stolen objects. Their composition, their metallicity, it's the word we use in astronomy, isn't consistent with all the other globular clusters, and neither is their motion. So the best explanation is we stole them. And yeah, they're just going to keep going the wrong way around. So Alara Sophia says, thank you. I can't, that's a donation, a pledge. I'm scrolling to the bottom. Thank you for the tip, Wayne Johnson. Thank you for the tip of $5. Thank you. Okay. I see both of you. Come here. I know. Come here. Okay, so Malachi's not quite ready to be on camera, and Eddie's not quite ready to not be on camera. So Alara Sophia says, hello, I was wondering why you were unwilling to accept the reason for the star's orbit being as described in the theory discussed. So it's not that I'm unwilling to accept it. I'm just unwilling right now to say, wow, my dogs are totally screwing up the camera right now. Pardon me while I try and put things right. I have no idea how long it's been screwed up. It's still not perfect. It's slightly better. It's more that I'm not willing to say this is the only explanation for this star. It seems kind of crazy to me that they can look at the star's orbit and composition and say precisely what happened 11.6 billion years ago. Our galaxy has gone through a lot over the past 11 some odd billion years. So I think this is one valid explanation for the history of this star. I don't think this is the only valid explanation for the history of this star. It's a really good question. I'm sorry I didn't explain it better during the episode. So scrolling. Thank you for the bits. I know. So I don't know if you're noticing, but Eddie keeps Eddie keeps switching sides just in case there's more treats on the other side. Okay. Oh, there are going to be more treats. There are. Yeah, you didn't have a chance to get to the other side, did you? Here. Come here. You can come here. Malachi's like, no, I can't come here. I am afraid. All right. Okay. Get down, monster. All right. I love my monsters. Thank you. Yes, our Instra was involved in last week's rocket update. I should have mentioned him as well. Scrolling. So Henny asks, can anyone present at AAS, or do you have to be picked by a special committee? Anyone can submit to present at the AAS. They then decide who's allowed to give a 5-minute oral presentation, and everyone else is asked to present as a poster. There's a $650 registration fee, and of course you have to travel to the conference. There are posters presented that are garbage science, that are just plain garbage. Made up stuff, crazy stuff. Occasionally they even get orals. But everyone has to pay. And there is literally a price to science. Broken symmetry, I'm not quite sure what you mean about nice to see the yellow did not soak in. Oh, The yellow in the press conference hall. It's true. So there was a definite issue of color balance at AAS. Um, so Guido says, maybe not science related, but how was the food? You tweeted something about your allergies hitting because of mango. Yeah. So every time I go to Hawaii, I learn new things about cross reactions of allergies. Um, so allergies are caused by an overactive immune system or an immune system that simply has no idea what it is actually supposed to attack. In my case, my immune system doesn't always fight the things it's supposed to fight, but really is good at fighting things that it shouldn't. So I have a sulfa allergy, and that led to me last time I was in Hawaii having horrible reactions to the volcanic fog on the Big Island. This trip, I purposefully stayed on the island of Oahu, where Honolulu is, and thought I would escape. But since I was last in Hawaii, I've developed a latex allergy. Latex comes from the rubber tree. And what I learned on this trip when I adopted a policy of no mango left uneaten is that mangoes, along with a number of other fruits, are enough related to the natural rubber tree that they have some of the same proteins in them and trigger the same allergic reactions. So by my second day there, I was swollen and in pain, like every joint in my body hurt. And I went Googling to figure out why on earth I was swollen and hurt and learned no more mangoes in my future. So by the end of the trip, I was starting to feel better. I've now been home for 3 days and I feel completely fine. I am simply sad because, well, there's a whole lot of different things that now I know I'm not allowed to eat. This is an unwanted diet plan, people. An unwanted diet plan. All right, too much information. So Gideostar asks, is the solution to Starlink to launch more orbital telescopes in a constellation of small orbital telescopes? So it's complicated. Starlink and other constellations of communication satellites are the next step that is needed to create global internet and easy access to information for populations in remote parts of our world. This is how we level the digital divide. The argument that we heard being made at the American Astronomical Society meeting, however, was that the simple act of having these having these low Earth orbiting satellites, which are often visible to the unaided eye, is going to steal our celestial heritage from the next generation, who, when they look at the sky, will see from dark sights side by side with the galaxy, all these satellites whipping around with 5 to 10 being visible at any given moment. Now, I personally enjoy looking at satellites, and the sky is awful big, and I don't think this is a cultural heritage issue. But that's one of the arguments that's being used. One of the real issues is currently Starlink, the way they were originally built, they reflect far more light than was anticipated, and they're so bright that they can actually blow out the detectors on astronomical devices. And the result is that if you take an image with a Starlink passing through it, the next several images are going to still have that Starlink's ghost appearing on the detector, where the detectors just aren't as sensitive after getting saturated. But Starlink is currently working with astronomers to try and figure out how to fix that problem. There's solutions. And the question becomes, do you want it to be a little harder to do astronomy, taking 5 to 20% more time to acquire necessary images, but give the world access to information and the ability to learn online? Or do you want to say no internet to rural peoples, let's keep it easy for astronomers? I personally think that we can, through improvements in detectors, software, we can overcome the challenges of having to, well, sit on a field a little bit longer and put up with Starlink and all the other constellations that are going to be necessary. And that is the morally correct thing to do in a world where currently the costs of laying fiber optic across the ocean, the costs of building the infrastructure to get internet to rural and remote parts of northern Canada, central Australia, so much of Africa, well, this is a solution. So what world do you want to live in? I'm okay with a few satellites. All right, scrolling back, and Twitch ate my chat. All right, I have no clue what has been said since that question that I just answered. I'm sorry. Can you type your questions back in? I got a text message, and apparently text messages eat Twitch chat on phones. Bad Panda points out, seems like light pollution is a bigger threat to the night sky. In many ways it is. Light pollution limits our ability to see things full stop. There are many dark sky parks, refuges around the world. And we need to take multiple measures to protect our ability to do science. Building telescopes in exceedingly remote locations. I don't know what that noise was. Whatever that noise was from, thank you. Binary Blaze is like, sorry, that's my fault. All right. Are you sinking bits? So I don't know what just occurred on chat. Streambot isn't telling me. Patreon pledges. Oh, thank you, Patreon humans. Thank you so much. Thank you, everyone who's joining us on Patreon. That is the number one. My dog's now trigger on thank you. That is the number one. Thank you, everyone pledging over on Patreon. Whoa. Hi. That's the number one best way you can help us. And it allows us to get you information on an ongoing basis. I don't quite know what triggered all of the Patreon goodness right now, but you are amazing. I love all of you currently. Thank you. Thank you. It's just going to keep coming. I'm okay with this. I am okay with this. Yeah, it's not renewals, Binary Blaze. That's not how it works. So I'm not quite sure what just generated. Whoa, something just crashed. Okay, Streamlabs is just like, and no. Thank you, guys. Thank you. Yeah, DPI 209 is right. It may have just triggered all the pending notifications. Oh, Binary Blaze is like, it was me. Thank you. Get a Star is like, what science could I do if I set up a small radio telescope and drift scan the sky? A small radio telescope. I don't know. I'm sorry. So drift scanning the sky with a small one would allow you to potentially spot asteroids or meteorites rather, that are coming through the atmosphere and reflecting back radio signals. Look at the stuff that's coming out of Manchester in England. They've been doing some good work with basically counting things during meteor storms using a large field non-drifting, so basically just pointing up. I need to think on that. I'm sorry, I just don't know the answer right now. So Raj Luther's commenting on, astronomers may have discovered the origin of fast radio bursts to a dwarf galaxy. So the fast radio burst story is actually way more complicated, which is why we didn't initially cover it last week and brought it up yesterday. So for those of you who don't know, fast radio bursts are massively powerful bursts of radio light that crop up for just moments. And as these fast radio bursts crop up, most of the time it's just this single burst that we don't have enough information on to even figure out really where exactly in the sky it's coming from. A few of them have been spotted to repeat, and we have so far been able to localize the position on the sky of two fast radio bursts. One of them is identified with a star-forming region in a spiral galaxy, and the other is identified with a dwarf galaxy. These are two very different environments, and we can't figure out if fast radio bursts are one kind of object, multiple kinds of objects. All we know is they exist, and some of them repeat. So the fact that we've identified the location of one didn't really give us enough information. It's frustrating. It's frustrating. So, looking to see what else is in here. So Hanny asks, what would be required to be able to better triangulate these entities? The ability to purposefully observe them rather than to just keep finding them in radio archives when they were observed while folks were trying to observe something else. It takes concerted efforts to figure out where on the sky a signal is coming from. And being able to know right now we're going to observe a radio burst, yeah, sadly, we can't do that nearly often enough. One of the crazy things about radio bursts that Susie brought up yesterday is Parkes Observatory in Australia, while trying to figure out what these suckers are, inadvertently discovered that microwave oven doors, when the microwave unit doesn't shut off fast enough, create radio bursts. So yeah, for a while it was thought all of these are actually just microwave ovens. No, not actually the case. So yeah, very confusing. All right. So I'm going to go ahead and end things here. I'm still working on recovering from all my travels. This afternoon, one of our CosmoQuest programmers is going to come over and help me clean up some code. We're probably not going to be coding while we're doing that because I think we're going to set up my dining room table, which isn't set up for streaming. But later this week, I will be streaming, including tomorrow after Annie's stream. So if you want to get involved in us putting CosmoQuest into a new form, check us out over on Discord and let me know that you want to be one of our coders as a volunteer and help us put citizen science open source. And I will give you access to our Coders Den, where we talk about all things software and sometimes just make fun of software languages because we can. But that's all I've got for today. I just want to remind you once again, we are a production of the Planetary Science Institute, a 501c3 nonprofit dedicated to exploring our solar system and beyond. We are produced by Susie Murph, and tomorrow, our own Annie Wilson, Binary Blaze, will be here bringing you Rocket Wednesday. So we're supported by you. If you can't afford to support us financially, we totally get that. But can you help us get the word out? Can you leave us a review in your favorite podcast directory? Can you, let people know that we're here live on Twitch and coming out on, whatever your favorite podcast player might be as the Daily Space. So thank you, everyone. And Annie, I know you're in Streamlabs. Can you start the credits rolling? Because I forgot to do that before I got started. Here's to hoping. There we go. So wherever you are in the world, have a fabulous morning, evening, or afternoon. And I'll see you on Thursday on the other side. Bye-bye.